Before starting limit, there's one topic left, which is composition of function and composition of relation that we will cover in this video. Two functions are given. Okay, let's say you have set A, set B, and set C. F is a function from A to B, and G is a function from B to C. Okay, so we have another function which is GOF, and that GOF is from A to C. This function GOF, this is from A to C. GOF is G of f of x. For any input, let's say A1, A2, and A3, and if G is a function, let's say this is B1, this is B2, B3, B4, B5. If G is a function from B to C, it means that G, by rule G, each element of B gets uniquely mapped to the elements of C. Okay? So, and f of x is what? F of x is what? So G, and in it, as an input to G, you will get what? You will get range of f. And range of f is a subset of B. Range of f is a subset of B, and B is the domain of G. So it means that for all of whatever will come here, all those elements are valid input to this function G. Means for all such values of fx, you will get a value of C, and so that will map the element of A with C. A1 is mapped to B2. Okay, then what is GOF of A1? GOF of A1 is equal to G of f of A1. Clearly, f of A1 is any one of the element of B, and any element of B will have an image in C by the rule G. So let's say B2 is mapped to C1. Then GOF of A1 is equal to what? GOF of A1 is equal to C1. Okay, so simply if you want to know the order, of it, go in the reverse manner. Means that, first of all, you have to go through a transformation of f. A function is also called as transformation. So it's like you give an input to f first, f will give an output, and that output is served as an input to G, and then it will give an output. Now this input is from set A. Okay, this input is from set A, and this is an element of set B. Okay, and this is element of set C, because G takes an element from B and gives a C. So this is the composition of function. So from any element xi belonging to A, or let me write it as ai belonging to A, if first you will apply f to it first, then after you get the image in the set B, then you apply G to it and you get set C, any element of set C, and this is your mapping for AI. Okay, if you get, let's say, Ci, so this is your mapping. GOF of AI is equal to Ci. Okay, so this is the composition of function. For any two given function, you should know that the codomain of one is the domain of the other. codomain of F is domain of G, so GOF is possible. Okay. If I say that, let's say there is another function H is there, another function H is there, which is from B to C. H is from, there is a function H that is from B to C. Then can I say that GOH is any function? Can this be a composition of function? If you want to go in this manner, then first you have to apply H to any input, because first we have to apply H to any input and then G to the output of H, and then this should be the result. But the input to H should come from B, input to H should come from B, and output of H comes from C. G is not getting its input. The domain of G is not C. Okay. So the for composition of function, if I say that GOF is possible, GOF is possible, it means what? It means that if we say that GOF is possible or it's a valid composition, what does it mean? It means that the codomain of F is domain of G. Okay. Okay, I'm erasing this one now. Now look at this. This is your A, B, and C. F is from A to B. G is from B to C. Okay. Then what should be the composition of function? Is it fog? No. Because what is the range? What is the codomain of G? Codomain of G is C. C is not the domain of F. So fog is not the composition. Is GOF the composition possible between these two functions? Yes. First you will apply F and then you will apply G. It means that the codomain of F should be the domain of G. So codomain of F is B and domain of G is B. So yes, GOF is possible. For F, for every element of A, there should be a unique mapping. Let me do it. Okay, this is interesting. This is interesting. Because the number of elements in B is less than the number of elements in A, then it is guaranteed to be many one. It cannot be 1 1. Okay, let's do it. 1 4, 2 and 7, 3 and 8. I am mapping it randomly. Okay, 4 and 8 and 5 and 4. G is from B to C. Now in this case 1 1 is possible. 1 1 is possible. From B to C, we can make G 1 1 because the number of element in the codomain is more than the number of elements in the domain. So let's make it 1 1. 4 and 9, 7 and 8, 8 and 6. Now what will be GOF? Now GOF will be from A to C. GOF will be from A to C. Okay. And what are the pairs in it? 1 is related to 4. 4 is related to 9. So 1 and 9. 2 is related to 7. 7 is related to 8. So 2 and 8. 3 is related to 8 and 8 is related to 6. So 3 and 6. So GOF is 1 1. Okay, so F is a function from A to B and G is a function from B to C. So what is the possible composition? The possible composition is from A to C, okay, and that is Goff. Okay. Now, now we will see different scenarios that if f is 1 1 and g is 1 1, when both f and g are 1 1, when f is many 1 and g is 1 1, all of these different scenarios, let's take all those. So you have f here and you have g here, and based on f and g, what the Goff will be. Like in the last example, f was many 1 and g was 1 1, and the Goff turned out to be 1 1. But is it universal? Will this happen all the time? That's what, let's see. Many 1 means that there will be more than one element, at least there will be some elements of A that will be mapped to one element alone. Let's say for these elements, it is mapped to just one element. So this is your A1, A2, A3, A4, and this is B1. Let's say it is mapped to B1. Then B1 is mapped uniquely to some element, let's say C1. What does it mean? It means that in your Goff, for all A1, A2, A3, A4, they all will be mapped to C1. So it will become many 1. So when you have many 1 and 1 1, when you have many 1 and 1 1, they will be many 1. F is 1 1, but G is many 1. Then what Goff is? So in case of Goff, codomain of F and domain of G should match, but the input to Goff will always be the range of F, right? F of A3, F of A4, they are all a different element of B, okay? It and G is many 1, no doubt, but it may be possible that G of f of A1, G of f of A2, G of f of A3, G of f of A4 may go to different elements. Okay, because you don't know, maybe B has n elements, maybe B has lot of elements, more than, means number of elements in B is much more than number of elements in A. If that is the case, then for it then there is possibility that all of this will also go to different elements, means all of these are also different. G of f of a1, G of f of a2, G of f of a3, G of f of a4, they all are different in C. It may be possible, and if that is the case, it is 1 1. Or it might also happen, because G is many 1, that some of them are going to same element, then it is many. So it can be Goff maybe many 1 or 1 1. Depends on the given function. Means we cannot say for sure what is going to happen. Like in this case, f was many 1. If f was many 1 and G was 1 1, then Goff has to be many 1, because for all those elements of f that maps to the same element, then this will have one mapping. So it means all of them is getting mapped to the same element. So if f is many 1 and G is 1 1, then Goff is many 1. But when f is 1 1 and G is many 1, we can't say. We have to look at the given function. F is 1 1 and G is also 1 1. Then it's easy. Then Goff is 1 1. If f is 1 1, it means f of a1, f of a2, so on, f of an. Let's say there are n elements in A. All of them are different. And when all of them are different, it means G of f of a1, G of f of a2, G of f of an, they all are different, because G is also 1 1. So what does it mean? It means that Goff is also 1 1. What I am saying is this: when you have all these elements going to different elements, so a1 a2 all these are different elements, so their image is also going to different elements in B, and because G is also 1 1, so for different elements the images are different in C. Okay, what is the other possibility? The last possibility is that you take both many one. Then what is Goff? Whenever f is many one, whenever f is many one, Goff will be many one. And we have, the reasoning is very simple. Just the first case, if it is many one, it means that if for a set of elements, let's say a1 a2 a3, you are that is mapped to the same element. Now if this b1, of course, just a set of elements getting mapped to the same element, now this will be mapped to one unique element in C, but for all these elements this is what the common mapping is, and so it will always be many one. So if f is many one, then Goff is always many one, and it is 1 1 when both are 1 1. But if f is 1 1 and G is many one, then we can't say about Goff as a general rule, but for a given function we will look at means specifically looking at the function, we can come to the conclusion for that particular function. Thank you very much. If anything is left, I will cover in the next video. Of course, yes, composition of relation is left, and we will see that in the next video. Thank you very much.